Here you need to work very carefully. In the first expression, every time you see x, substitute with x plus h, and you need to pay attention to the signs. And then we need to work on a common denominator. So we need to multiply some stuff here. It makes for a long expression. For instance, the common denominator, as before, would be the product of a trinomial times a binomial. So it would be 2 plus x plus h times 2 plus x. We are not going to actually calculate that because we know that at the end we're going to just substitute h. So there is no reason to clear the parentheses in the denominator. Okay? However, when we find the new numerators, here we need to do some arithmetic or algebra. 1 minus x minus h, okay, when you clear the parentheses, minus h times 2 plus x, okay, and here, after, if you remember, fraction bar is the same as parentheses, so really the top is x minus 1, if you think about it. So I'll change it to plus here, and I'll write x minus 1 instead of 1 minus x, so I don't need to worry about the negative up front, and then I'll multiply it by 2 plus x plus h. So if you look at the total, you have a trinomial times a binomial and a binomial times trinomial, total of 6 plus 6. You're going to have as 12 monomials. Most of them will be reduced or cancel each other, but the next step will produce a numerator that is 12 monomials long. Okay? So this is where you need to be careful with your bookkeeping or housekeeping. Let's see. Nothing happened here, but now we're going to start multiplying. Okay, so what I'll do the first, I'll just FOIL. So, and I'm doing just the numerator at this point. So I have 2 plus x, and now negative x, so I have negative 2x, and negative x squared, and now negative h, so I have negative 2h, and negative xh. 1, 2, 3, 4, 5, am I missing something? 1, 2, 3, 4, 5, 6. I'm done here. And now I'll multiply x by the trinomial, so I have plus 2x, plus x squared, plus xh, and I'm almost out of room here, so I'll write it on top. Now I have negative 1 times this, so it will be minus 2, minus x, minus h, like so. And I squeeze the last 6. And now the denominator will stay the same. Okay, no need to mess with the denominator. And now we need to see what survive of the 12 monomials, what will survive. Okay? Can I cancel the 2? Yes. I have the 2 and the 2. Okay? Can I cancel the x? I have x, positive x and negative x. Can I cancel the negative x squared? Yes. I have positive x squared. Can I cancel the negative 2x? Yes. Okay. What else? xh here and xh here. Negative and positive. Thank you. So what's left? Minus 2h minus h. That's it. We have 6 pairs. We cancel 5 pairs. We have only 1 pair survive the cancellation. So we end up 2h. So this survive and this survive. Okay, so we have minus 3h over this long denominator. And of course, as before, the h and the h cancel out, and we end up having the limit as h approaches 0 of negative 3 over the denominator. And now we can substitute. Again, why? Because when h equals 0, we have 2 plus x times 2 plus x. The function is defined when h equals 0, so we end up having negative 3 over 2 plus x squared. And notice that there is some similarity between this result and the result from before, right? What is the similarity? We got negative and we got negative, right? And we have the denominator, the original denominator was x minus 1. We end up having x minus 1 squared. The original denominator was 2 plus x. We end up having 2 plus x squared. So you probably think, man, must be a rule here. Must be a shortcut here. Indeed there is. And this is a good time to start talking about those shortcuts, I think. Even though